Okay, Assalamualaikum and very good afternoon. How are you today? We continue our lesson about limit and continuity, subtopics vertical and horizontal asymptote. Our objective today, first, find the vertical asymptote. Second, find the horizontal asymptote. Definition of vertical asymptote. A line x equal to a is a vertical asymptote of the graph of a function y equal to fx if either limit x approaches to a from the left fx equal to positive infinity or negative infinity or limit x approaches to a from the right fx equal to positive infinity or negative infinity. This is the definition of vertical asymptote. Steps in finding the vertical asymptote of a rational function. First, make sure the function is in the simplified form. For example, fx equal to x plus 2 over x squared minus x minus 6. X squared minus x minus 6 we can factorize and then we can simplify. And then this is not a simplified form. So we can reduce to fx equal to x plus 2 over x plus 2 x minus 3. So x plus 2 with x plus 2 we can cancel here. So fx equal to 1 over x minus 3. Okay, this is a simplified form. Number 2, step 2, find the value of x that cause the denominator to be 0. Kalau kita lihat example atas, nilai x yang akan menyebabkan denominator menjadi 0 adalah x equal to 3. Okay, step 3, if x equal to a cause the denominator to be 0, then confirm whether x equal to a is a vertical asymptote by finding limit x approaches to a from the left fx equal to positive or negative infinity, or limit x approaches to a from the right fx equal to positive or negative infinity. So we have 3 steps how to find the vertical asymptote of the rational function. Okay, look at example 30. Find the vertical asymptote of fx equal to 1 over x square. Okay, pertama kita tulis dalam bentuk terringkas. Fx equal to 1 over x square memang tak boleh nak ringkaskan. So, inilah bentuk terringkasnya. Langkah yang kedua, cari nilai x yang menyebabkan denominator become 0. In this example, x equal to 0. So, we find the limit. So, limit x approaches to 0 from the right fx. Limit x approaches to 0 from the right. This is from the right here. It's a positive from the right. 1 over x squared, we get a positive infinity. And then find the limit x approaches to 0 from the left. This is from the left. Fx, that means limit x approaches to 0 from the left, 1 over x squared. Also positive infinity. So thus the line x equal to 0, x equal to 0 is a vertical asymptote of fx. Determine the vertical asymptote of a fx equal to x plus 3 over x plus 2. Okay, this is a simplified form, and then the denominator becomes 0 when x equal 2. X equal negative 2. So we find the limit, confirm with limit, limit x approaches to negative 2 from the left, from the left here. That means nilai x itu akan kecil daripada negative 2. Kalau nilai x ni kecil pada negative 2, okay, this part become a negative. Okay, this will become negative. Okay, this is also, you substitute negative 2 here, you get a 1. So you get negative 1 over negative. You akan dapat nilai yang negatif sebelum dapat 0. So the answer is negative infinity. Limit x approaches to negative 2 from the right. Negative 2 from the right. If you substitute negative 2 here, you get 1. And then this is a positive 2 in 0. So the answer is positive infinity. So we can conclude that the line x equal to negative 2 is a vertical asymptote of fx. Okay, B, fx equal to 1 over x squared minus 1. First, we find the value x for denominator becomes 0. So x squared minus 1 equal to 0. So x equal to negative 1 and x equal to 1. For x equal to negative 1. Okay, we find the limit x approaches to negative 1 from the left, 1 over x squared minus 1. Okay, let's say you can test any value close to negative 1 from the left. Let's say negative 2, negative 1 from the left. This is a negative 1. You can test here negative 1.1. Negative 1.1 square, you get a greater than 1, so you get a positive value here. So the positive. So nilai dia adalah positive infinity. And limit x approaches to negative 1 from the right. From the right, you come from this way. From the right, that's mean negative 0.9. You can test with negative 0.9 here. Negative 0.9. Square, you get a value less than 1. So you get a negative. So answer is 1 over negative 0. So jawapan dia negative infinity. Itu satu cara kita uji titik yang hampir dengan nilai yang kita nak hampir itu dari kiri dan dari kanan. Kita tengok sama ada dia jadi positif atau dia jadi negatif. Okey, sekarang kita tengok for x equal to 1. Limit x approaches 1 from the left. From the left, this is a 1. From the left, that means you test with 0.9. 0.9 square less than 1. Less than 1 minus 1, you dapat atas ini memang positif. 1 ni memang positif. Divide by, this dia dapat negatif. Maka jawapan dia ialah negative infinity. And then limit x approaches to 1 from the right. From the right is 1 from the right. So we can test 1.1. 1.1 square is greater than 1 minus 1 is positive. So the answer is positive infinity. Okay, so that's the line x equal to -1 and x equal to 1 are vertical asymptote of fx. Dalam soalan ni kita ada dua vertical asymptote, x equal to -1 dengan x equal to 1. Okay, C. Determine the vertical asymptote of fx equal to 2x over x squared minus x minus 2. First, we find a value x for denominator becomes 0. So x squared minus x minus 2 equal to 0. We can factorize. You get x equal to -1 and x equal 2. Okay, we confirm with limit method for x equal to -1. For x equal to -1, okay, -1. From this is -1, this is -1, you come from the left. Let's say we can test with the value close to -1 from the left, -1.1. -1.1 times 2, you get negative. -1.1 minus 2, you get negative also. And then -1.1 plus 1, you get negative. But close to 0. This is close to 0, negative. So you get the answer equal to negative infinity. Okay. Next, find a limit x approaches to negative infinity. So this is a negative infinity. This is a -1. From the right, you come from here. So we can test. This is a value here. Negative 0.9. Negative 0.9 times 2, you get this is a negative 0.9 minus 2, this is a negative. Okay, this is a positive. Negative 0.9 plus 1 is positive. So negative, negative, positive. So you get the answer is positive infinity. Yeah, positive infinity. Okay, this is for x equal to 1. Therefore, we can conclude that the line x equal to -1 is a vertical asymptote of fx. So we can test the another line here, x equal to. For x equal to, limit x approaches 2 from the left. This is a 2 from the left. That means you take 1.9. 1.9 times 2, you get a positive. In negative, this is 1.9 minus 2 is a negative. This is a positive. So negative times positive is negative. So get an answer is a negative infinity. And then limit x approaches to 2 from the right. 2, this is a 2 from the right. From the right here. So this is a 2.1. 2.1 times 2 is positive. 2.1 minus 2 is positive. 2.1 plus 1 is positive. So you get the answer is positive infinity. Okey, oleh sebab itu, kita dapat satu lagi line x equal to adalah vertical asymptote. Sebab dia memenuhi syarat untuk vertical asymptote. Jadi kita ada dua garis yang merupakan vertical asymptote, x equal to -1 and x equal 2. Okay, next example, determine the vertical asymptote of fx equal to x plus 2 over square root x square minus 4. Okay, fx equal to x plus 2 over square root x square minus 4 ni belum lagi dalam bentuk terringkas. Kita boleh selesaikan, kita boleh ringkaskan sebab set x square minus 4 ni kita boleh tulis sama dengan x minus 2 x plus 2. So this equals set x minus 2 times set x minus 2. Okay, this is a set x square minus 4. And then darab dengan set x plus 2 and then set x plus 2. Supaya di bawah ni akan ada set x plus 2. Bila kita darabkan dengan set x plus 2, kita akan dapat x plus 2. Jadi kita boleh cancelkan. Okay, x plus 2, set x plus 2. Yang ini, kalau kita darabkan, kita akan dapat x plus 2. So, x plus 2 with x plus 2, we can cancel. Jadi, fungsi dia boleh tulis dalam bentuk yang terringkas. Set x plus 2 over set x minus 2. So, denominator ni akan menjadi undefined or 0 bila x sama dengan 2. So, limit x approach 2 from the right. In this case, fungsi ni hanya tertakrif untuk x yang besar daripada 2. So, kita hanya cari daripada kanan saja. Limit x approaches 2 from the right. So, kita akan dapat positive infinity. So, the line x equal to is a vertical asymptote of fx. Okay, next example. Determine the vertical asymptote of fx equal to x plus 1 over x square minus 1. Okay, kita boleh simplify dulu. Kita akan dapat x plus 1 you can cancel. Kita dapat 1 over x minus 1. So, limit x approach 1 from the left. This is a 1 from the left. Kita boleh cuba nilai 0.9. Kita boleh gunakan gantian nilai yang hampir dengan 1. Dari kiri, kita dapat positif ataupun negatif untuk menentukan dia positif atau negatif infinity. So, kalau you datang dari kiri, you akan dapat nilai dia lah 0.9 minus 1 is negative. That means negative infinity. And then limit x approach 1 from the right. That means from the right here. Kita ambil 1.1. 1.1 minus 1 is positive. So, kita akan dapat positive infinity. Ini maka line x equal to 1 is a vertical asymptote for fx. Ini baru pada x equal to 1. Kita ada, okay, ini kita dapat x equal to, sebab fungsi dia fx sama dengan 1 over x minus 1. Jadi kita ada satu saja vertical asymptote dia x sama dengan 1. Tapi kalau you tengok sini tanpa you simplify seolah-olah ada 2, iaitu x sama dengan 1 or x sama dengan negatif 1 kan. Tapi bila kita simplify sebenarnya vertical dia asymptote cuma ada 1 saja. Jadi kena simplify dulu baru kita dapatkan nilai limit dia. Okay, definition of horizontal asymptote. Tarikh bagi horizontal. Horizontal adalah garis yang mendatar. Vertical tadi ialah menegak. Okey, ni tarif bagi horizontal asymptote. A line y equal to b is a horizontal asymptote of the graph of the function y equal to fx if either limit x approach to positive infinity fx equal to b or limit x approaches to negative infinity fx equal to b. Tadi kita dapat infinity atau negative infinity untuk horizontal untuk vertical, tetapi untuk horizontal adalah limit apabila x menghampiri positif atau negative infinity apa jadi pada y, dan nilai ini adalah nilai horizontal asymptote dia. Y equal to b. Okey, tengok graf ini. Inilah garis y sama dengan 4. Ada satu fungsi fx dan fungsi itu kalau kita lihat dia semakin menghampiri garis y sama dengan 4 apabila x pergi ke x menghampiri negatif infinity. Maka kita boleh kata limit x approach to negative infinity fx equal to 4. 4x y equal to 4 itu dikatakan sebagai horizontal asymptote. Apabila x pergi ke negative infinity ataupun x pergi ke positive infinity. Okay, next example. Okay, gx when x goes to infinity, x pergi ke infinity. Nilai x makin pergi ke infinity, nilai y kalau kita tengok dia menurun sehinggalah dia menghampiri garis y equal to 0. So, y equal to 0 itu disebut sebagai horizontal asymptote. Okay, determine the horizontal asymptote fx equal to x over x minus 2. Kalau kita tengok kat sini, dia merupakan fungsi rational function. So, bila x pergi ke infinity, saya harap you masih ingat lagi, kalau x pergi ke infinity, maka kita kena divide every term by x to the highest power of denominator. So, the highest power of denominator equal to x lah kat sini. Okay, kita divide all term by x. And then you simplify. Tapi kita tahu kat sini, limit x approaches to infinity bagi 2 over x becomes 0. So, you get 0. So, you get 1. And then, sebenarnya dekat sini pun kita telah boleh buat kesimpulannya. Yang inilah nilai y. So, that means y equal to 1 adalah horizontal asymptote. Dan kita boleh cari sekali lagi menggunakan negative infinity pula. Adakah dapat jawapan yang sama ataupun jawapan yang lain. Bila x approaches to negative infinity, kita menggunakan kaedah yang sama. Divide every term, each term by x to the highest power of denominator. Okey, kita akan simplify. Akhirnya kita akan dapat jawapan yang sama satu. Jadi confirm y equal to 1 adalah y equal to 1 is a horizontal asymptote of fx. Okey, b fx equal to x plus 2 over square root x square minus 9. Okay, divide each term by x to the highest power of the denominator. Kalau you tengok kat sini, the highest power of denominator equal to square root x square. Square root x square. Square root x square actually equal to x lah. Okay, kita divide dengan square root x square. This divide by square root x square. Okay, square root x square actually is x. So x over x you get 1, 2 over x. And then this is the square root x square minus 9 divide by square root x square. Kita boleh hilangkan tanda square root tu, kita tulis macam ni. X square minus 9 over x square. X square over x square is 1. So you dapat 1 plus 2 over x, 1 minus 9 over x square. When x approaches to positive infinity, 1, 2 over x becomes 0. 9 over x square also 0. So you get the answer is 1. So hence y equal to 1 is a horizontal asymptote of fx. Okey. Sekarang kita tengok pula apabila x pergi ke negative infinity. Limit x approaches to negative infinity, x plus 2 over square root x square over square root x square minus 9 over is a negative, negative x square. Sebab bila x pergi ke negative infinity, nilai x adalah negative infinity. Negative x, negative x. So kita tulis negative kat sini. Okey, kita tulis negatif apabila yang melibatkan set. Bila soalan tu melibatkan set, oleh kerana x pergi ke negative infinity, maka nilai x itu adalah negatif. Jadi kita tulis dekat situ adalah negatif. So limit x approaches to negative infinity, kita tulis negatif. Jadi di sini x over x is 1, 2 over x, tinggalkan situ. Kemudian kita boleh ringkaskan x square over x square is 1. Kita dapat di 2 over x and 9 over x square. When x approaches to negative infinity, nilai dia akan jadi kosong. Maka kita akan dapat jawapan dia negative 1. Negative 1. Hence, y equal to 1 and y equal to negative 1 are horizontal asymptote of fx. Dalam soalan ni kita dapat dua horizontal asymptote, iaitu y sama dengan 1 dan y sama dengan negatif 1. Okey, itu saja untuk hari ini. Thank you. Dan kod bagiku kehadiran hari ini adalah ZBM03. Okey, bye-bye.